Hi, this is Jason Molesky. In this example, we'll take a look at performing a significance test about P. The potato chip producer of section 9.1 has just received a truckload of potatoes from its main supplier. Now recall that if the producer finds convincing evidence that more than 8% of those potatoes have blemishes, the truck is going to be sent away to get another load from the supplier. Suppose a supervisor selects a random sample of 500 potatoes from the truck and an inspection reveals that 47 of those potatoes have blemishes. Let's carry out a significance test at the 5% significance level and then determine what the producer should conclude. To do this, we'll follow our four-step process, starting by stating the problem. We want to perform a test of the hypotheses, the null hypothesis, p equals 0.08, against the alternative, p is greater than 0.08, where p is the actual proportion of potatoes in the shipment with blemishes. And again, we'll use an alpha equals 0.05 or a 5% significance level. Now under the plan step, we need to check our conditions. If they're met, we can do a one-sample z-test for the population proportion p. We took a single sample. We're interested in determining something about the population p, so that one-sample z-test is appropriate. Well, first of all, we need to check for randomness. Note the supervisor took a random sample of 500 potatoes from the shipment, so that condition is met. Next, for our 10% condition, we can state it seems reasonable to assume that there are at least 5,000 potatoes in the shipment. We'll assume it's a fairly large truck and there's lots of potatoes in there. Finally, we need to check our large counts. Now, assuming that the null hypothesis is true, the expected counts of blemished and unblemished potatoes would be 40 and 460 respectively. We find that by multiplying our sample size times the null p, the 0.08, and then our sample size times 1 minus that value. Now because both of these values are at least 10, we should be safe doing normal calculations. So it looks like our conditions are met and we're safe doing a one-sample z-test. Next, we'll finally do the problem. Now note the sample proportion of blemished potatoes is p hat equals 47 out of 500, or about 9.4%, 0.094. Now that's greater than our null hypothesis of 8%, but we have to determine if that's great enough to be considered significant evidence against that null. To do that, we start by calculating a test statistic. We standardize that value to find a z-score of 1.15. Next, we use table A or technology to find the p-value. How likely is it that we'd observe that particular sample or something more extreme, assuming that null hypothesis is true? In this case, either using table A or technology, we see that the p-value is 0.1251, or about 12.5%. Finally, we conclude. Now, because our p-value of 0.1251 is greater than our alpha level, we fail to reject the null hypothesis. In context, that means there's not convincing evidence that the shipment contains more than 8% blemished potatoes. As a result, the producer can use this truckload of potatoes to make potato chips. Now for some additional practice in performing a significance test about P, try exercise 39.